Welcome to Kindergarten Video on Demand. This video is an overview of Unit 4, 3D Shapes in My World. The purpose of this video is to provide an overview of the standards, intended pacing, and sample instructional strategies for Unit 4. In this portion of the video, we will review the AKS and Indicators of Achievement, or IOAs, for Unit 4. The AKS is the overarching knowledge and skills that students are expected to master. The IOAs are the learning objectives that allow students to demonstrate mastery of the AKS. The AKS and IOAs may not be taught in their entirety the first time they appear on the instructional calendar. Some AKS and IOAs will appear multiple times throughout the year. In Chapter 2 of the video, we will look to see how the AKS and IOAs in this unit are paced in detail. This unit has 4 AKS. Under the AKS, you will find the Indicators of Achievement, or IOAs. You will also see that we have provided you with a state coding at the end of the IOAs so that if you are looking up resources on the Georgia DOE website, you are able to find the state IOA that is related to the GCPS IOA. Unit 4 introduces 3-dimensional shapes. However, this unit will bring in the 2-dimensional shapes that we were taught in Unit 2. With AKS 8, students identify, describe, and compare basic shapes encountered in the environment. They also form 2-dimensional shapes and 3-dimensional figures. Our indicators of achievement help us better understand how students show mastery of AKS 8. IOA 8A states students should be able to identify 3-dimensional figures, including cubes, cones, cylinders, and spheres. Students identify and describe the shapes based on attributes. That's when we're going to be talking about the attributes of faces, vertices, and edges. It is important to use those shapes in different orientations and sizes, along with non-examples of the shape, so students learn to focus on defining attributes of the shape. With this IOA, students also need to compare 2-dimensional shapes to 3-dimensional shapes. For example, when looking at a square and a cube, students should be able to compare the similarities and differences. With Indicator 8B, kindergarten students should be able to explain the location of an object in relation to another object using positional language such as above, below, beside, in front of, behind, or next to. Indicator 8C states students use basic shapes to represent specific shapes found in the environment. Students do this by creating models and drawing shapes. Because this unit focuses on 3-dimensional shapes, when it comes to Indicator C, we are going to be spending our time creating models. The expectation is not for kindergarten students to be able to draw 3-dimensional shapes. The last indicator for AKS 8 is IOA 8D, in which students use 2 or more basic shapes to compose larger shapes. Students form or compose larger shapes by putting together smaller shapes through exploration and play. Students then progress to looking at images of larger shapes in which they decompose that large shape into 2 or more smaller shapes. In Unit 2, our work with Indicator 8D and our 2-dimensional shapes included we were composing larger figures out of 2D shapes as well as forming larger shapes. When it comes to our work with 8D in Unit 3, our focus is going to be how can we take those 3-dimensional shapes and put them together and compose a larger figure. We will not be using 3-dimensional shapes to make a new 3-dimensional shape like we did with our 2-dimensional unit in Unit 2. We can, however, and we might have students that realize that I could take, for example, 6 flat 2-dimensional squares and use that to form a 3D shape, which would be our cube. So that's the only nuance in there where we could take something to make an actual larger shape. Majority of the work will be making larger figures and then looking at things that have been built with the different 3D shapes and decomposing it into the smaller 3D shapes that were used to build it. AKS 7 consists of observing, describing, and comparing physical and measurable attributes of objects and analyzing graphical displays of data to answer relevant questions. IOA 8A states our students will directly compare, describe, and order common objects using measurable attributes. The measurable attributes that we work with in kindergarten are length, height, width, and weight. And we describe the difference between two objects using those measurable attributes. Our kindergartners will use language such as heavier, lighter, longer, taller, shorter, wider, larger, smaller. Students use a variety of techniques and tools to compare, describe, and order objects. Students may use a referent object being compared as a tool to describe the other objects. IOA 7B classify and sort up to 10 objects into categories by an attribute and count the number of objects in each category and sort the categories by count. Kindergarten students should sort up to 10 objects by an attribute in each category. Attributes may include height, length, weight, and width, as well as attributes such as color, number of sides, size, etc. After sorting by an attribute, students count the number of objects in each category and then sort the categories by count. We have done work with this IOA in earlier units. We will continue working with this IOA in Unit 4. And for the first time in Unit 4, we will add the portion of the IOA which says we will then sort the categories by count. Still going to work at the concrete level, but that is the last piece of this IOA will be introduced in Unit 4. The goal of IOA 7C is to use math to make sense of the world around our students and by asking questions that they care about and then collecting and gathering and interpreting data to answer those questions. Students display their data using objects and pictures, and students should be able to use friendly language to explain their data and answer the overall question. AKS 2 is an ongoing AKS in which students use the count sequence to count forward and backward in sequence. IOA 2A specifically states students count forward by ones and tens to 100 and backwards from 20, while IOA 2B has students count forward to 100, beginning from any given number within 100, and count backwards from any given number within 20. In Unit 1, our focus was on counting forward from 0 to 10 and backwards from 10 to 0. In Unit 2, we built on this work and extended our count forward sequence to 50. In Unit 3, we started counting backwards from 20 and forward from any given number within 50. In Unit 4, our focus will be counting forward 0 to 100, and then for IOA 2B, we'll count backwards from any given number within 20. There are no specific lessons designated to this AKS in our Unit 4. Instead, our work with AKS 2 will occur during activating strategies as we practice our rote counting through counting routines. For students to show mastery of AKS 6, students should create, extend, and describe repeating patterns with a repetition not exceeding 4, as well as describe patterns involving the passage of time. AKS 6 is ongoing throughout the year. In Unit 4, IOA 6A will focus on extending and describing repeating patterns with 2-dimensional and 3-dimensional shapes at the concrete level and explain the rationale for the pattern. In later units, students will create patterns, work with number patterns, and move to representational work with patterns. IOA 6B states students describe patterns involving the passage of time using words and phrases related to actual events like now, later, yesterday, tomorrow, morning, evening, or days of the week. This IOA should be taught throughout the year. This indicator will not have specific lessons devoted to it. Instead, students will work with this IOA in activating strategies and in conversations about their days as they describe patterns related to time from real life.
The pacing guide is an example intended to model how instruction of the AKS and IOAs in each unit may be facilitated, but teachers should design pacing to be responsive to the learning needs of their students. Let's take a look at our pacing guide for Unit 4. In the box, which names the unit, you will see the suggested pacing. For Unit 4, we suggest about 4 weeks. The big ideas, geometric and spatial reasoning, measurement and data reasoning, for the unit are included, as well as any links we feel would be beneficial for the entire unit. Next, you will see a list of the AKS and IOAs which have been strategically clustered together. This is followed by our suggested pacing. Specifically, the left column provides the learning progressions for the AKS and IOAs, whether this be the concrete, representational, or abstract progression, or the progression between specific learning targets within the IOAs. Suggested manipulatives are also included in this column. The right column provides resources to guide instruction. We will begin our work in Unit 4 with AKS 8, in which we identify, describe, and compare basic three-dimensional shapes encountered in the environment. The suggested pacing for our work with AKS 8 in this unit is about 8 days. During this time, we will spend approximately 5 days at the concrete level, in which we will introduce a shape each day and create an anchor chart to support students as they identify and describe the attributes of three-dimensional shapes. We will classify shapes of different sizes and orientations, as well as sort shapes into examples and non-examples. Students should also be able to compare two-dimensional and three-dimensional shapes by explaining the similarities and differences. During this time, we will also create models using basic shapes to represent specific objects found in the environment. After our concrete work with shapes, we have one suggested day of embedding IOA 7.C at the concrete representational level with a task-based lesson. Then we will transition to the representational level with a suggested pacing of 2 days, in which we continue to identify, classify, and sort real-world pictorial representations of 3D shapes in different sizes and orientations. Next, our focus will shift to IOA 7.A, where students will directly compare, describe, and order common objects using measurable attributes. We should suggest about 10 days, with the majority of the days at the concrete level. The first day is paced for an inquiry lesson where students are able to explore measurable attributes through hands-on experiences. Students will then dive deeper into each measurable attribute with a suggested pacing of 2 days for each: length and width, height, and weight. Students are expected to describe attributes of an object, directly compare two objects, and order objects. We will wrap up Unit 4 with IOA 7.B, with a suggested pacing of about 2 days, where students will sort objects into categories by an attribute and count the number of objects in each category. Students will then sort the categories by count. As a reminder, the number of objects in each category should not exceed 10. This means there may be a total of more than 10 objects, but after the objects are sorted, there will be 10 or less in each category, allowing students to count the number of objects in each category and represent the amount with a written numeral. This portion of the video will highlight specific instructional strategies that will be utilized in this unit. Please refer to the Analyzing the Standards for guidance on additional instructional strategies for each IOA. Now let's take a look at possible instructional strategies in action.
In Unit 4, our work with AKS 8 will focus on three-dimensional shapes. We learned about two-dimensional shapes in an earlier unit. We will incorporate 2D shapes with our learning as we compare two-dimensional and three-dimensional, but the majority of our work is going to be at using those three-dimensional shapes. So let's look at the different IOAs we have and think through what our instructional strategies may be. So if we look at our IOA 8A, it says that we're going to identify, sort, classify, analyze, and compare our shapes. Specifically, the three-dimensional shapes that we're going to be working with are cubes, cones, cylinders, and spheres. And we do want to use those in a variety of sizes as well as orientations. But let's go ahead and talk about the identify portion of this IOA. When we're identifying shapes, three-dimensional shapes, we do want our students to touch them. So we want concrete. They can be foam shapes or the shapes that you get in your math kits, but it can also be real-world examples of these shapes as well. They need to touch and feel them so that they can really learn about those attributes. The more they touch and feel, they're going to understand what it means to be a face. It's the flat side of the shape. So like for our cubes, we have our squares that are our faces. They're in the shape of a square because all sides are equal, but those are our faces, and there are 6 faces on a cube. We also want them to learn about the vertices or the corners. So we know our cubes have 8 vertices. They have 6 faces, and then they have 12 edges. And edges are the lines where our faces meet. So this top face and this side face, they meet at this line, and that is one of the edges. So those are the attributes that we're going to be using to identify our shapes. If I don't know, I grab another one and let's say I grab a square. I know that's not an example of a cube because it's flat. It doesn't have 6 faces. It doesn't have 8 vertices or 12 edges. So this is not an example of a cube. Our cubes are solid shapes, and this square is a flat shape. And it is okay if our students use solid and flat instead of using the terms two-dimensional and three-dimensional. So I know all of our IOA and AKS says two-dimensional and three-dimensional, but we can go with flat and solid. Now we're going to be analyzing the shapes with everything that we do. When we're identifying them, we're having to analyze them based off of their attributes. When we sort, we're going to be analyzing them based off of those attributes. So we want to know those attributes of each of the 4 solid shapes that we're supposed to know and learn about, which are the cube, cone, cylinder, sphere. So we'll be talking a lot about faces, vertices, and edges. After our students have identified concretely and they've touched and they've learned about these attributes, they may be able to recognize this in the representational level. So I could see a picture of a bunch of shapes and just decide which one is the cube, which one is the cylinder. When we sort, this is where we're going to be using examples and non-examples, and we'll be justifying that with what we know about the attributes from our first couple of days of just getting to learn the shape. So, for example, maybe I'm going to go ahead and sort these into which ones are examples of cubes and which are not. Well, I know this one is a cube because it has 6 square faces, 8 vertices, and 12 edges. This one, so that's an example of a cube. Let me stick it over here. This is not an example of a cube. It does have 6 faces if I count them 1, 2, 3, 4, let me do it so y'all can see it. The top and the bottom, that's 1, 2, 3, 4, 5, 6. But those faces are not in the shape of a square. They're not all equal sides. So this is not an example of a cube. So we can sort based off of examples and non-examples. We can sort all the cubes here, all the cylinders. I know these are cylinders because, and I'm going to go back to those attributes. Here's my cones, here's my spheres. So I can sort into groups based off of those attributes. We can compare and analyze three-dimensional shapes. So I can look at my my cube and let's say my cylinder, and I can compare them and notice that they both have faces. But a way that they're different is that the cube has vertices and the cylinder does not. It doesn't have any points on it where the faces and the edges meet. So this has 8 vertices. This has no vertices. So I can compare different three-dimensional shapes. I can also compare 3D shapes to 2D shapes, so my solids to my flats. What do I notice? Well, I notice that this is 4 equal sides. It's flat. This one's solid, so that's a way they're different. But a way that they're alike is the fact that my cube is made of squares. So the faces are in the shape of a square. I just have to put them together and to make it to where it's solid. So they will be doing some of that comparing between 2D and 3D. As we continue to work with shapes, we will describe the relative location of objects using positional words. This we can actually probably integrate some with our 8D, where we use three-dimensional shapes to compose larger figures. We're not going to compose larger like 3D shapes. But for example, and I'm going to do this, I would normally like stack these on top of each other. So I just put a cube on the bottom, then a cylinder, and then a cone. So I've kind of made like a little building. I'm going to turn it this way for the purpose of you guys being able to see it. But I can use my positional words and talk about how the cone, I placed it on top of the cylinder, or the cylinder is in the middle of the cube and the cone. So I can use those positional words to describe as I'm building composite figures. And then I can also say, well, here is my building, and I can break it apart and say, well, it's composed of 1 cone, 1 cylinder, and 1 cube. Again, of course, this work is all going to be done at the concrete level with each IOA before we move into the representation. When it comes to 8C, we will build our three-dimensional shapes that we see out in the world. So for example, if I see that the basketball is in the shape of a sphere, I could then use clay or Play-Doh and roll it up into a ball, and I've created a model of what that basketball looks like. So I'm taking a real-world object that I see in my environment, and now I'm creating a model to represent it. We don't expect our kindergarten students to be able to draw 3D shapes at the representational level. So we won't draw. We can create models at that concrete level. I can make a cube with pretzel sticks and marshmallows, or toothpicks and marshmallows, or craft sticks and marshmallows, or I can make shapes out of Play-Doh, but we're not going to need to draw those shapes. So our work with AKS 8 and our three-dimensional shapes will be very much like our work was with our two-dimensional shapes earlier in the year.
In Unit 4, students will begin to work with IOA 7.A, where they're going to directly compare, describe, and order common objects using measurable attributes. These measurable attributes include length, height, width, and weight, and we want them to be able to describe the difference. So in looking at this first part of the problem, it says describe the length of your pencil. So if I have my pencil here, we want students to be able to use words to describe these measurable attributes. So if I'm talking about length, I can say the pencil is short or the pencil is long. If I'm talking about the weight of the pencil, I may say the pencil is light or the pencil is heavy. And then we want students to be able to compare two objects to one another. So if I'm looking at the length of my pencil, I may then compare it to the length of my friend's pencil. So I am going to teach students that when we are comparing length, we need to make sure that our ends are lined up and that they match. We don't want students to look at objects like this and think that this pencil is longer than this pencil because we have not lined up the ends. So that's important for students to know. So we're going to line up the ends, and I can compare the lengths by saying my pencil is longer than my friend's pencil, or my friend's pencil is shorter than my pencil. And then we may have a third friend come with their pencil. So now that I already know the order of these two pencils, now I have a third pencil, and I am trying to determine where this pencil would go in relationship to my pencil and my friend's pencil. So again, I want students to line this up. Oh, so I can see that the new pencil is shorter than my pencil and it's shorter than my friend's pencil. So I can order this from shortest to longest like this. And students are going to need lots of experience, hands-on concrete experience with this in order to be able to see this. And you can do the same with weight, using the bucket balance and putting an object on one side and an object on the other and looking to see which one is heavier and which one is lighter. Students also need to be able to look at an object and, for example, let's use this pencil, and now compare it to objects and determine if these objects are shorter than the pencil or longer than the pencil. So I'm going to take a pair of scissors and I'm going to line these objects up. I can see that the scissors are longer than this pencil. So my pencil stays in the middle. I'm going to move this side is going to be longer than the pencil. And we would want to label this for students so that they can see that these objects are longer and on the other side, I'm going to put shorter. And you may want to make a chart for students where they are able to sort objects. Okay, and in the middle, where we would put objects that are the same length as this pencil. Okay, and so I'm going to always compare it to my pencil. I have a paper clip. Again, we want students to line the objects up at the bottom. I can see the paper clip is shorter than the pencil, so I would move it over here. I have a bottle of hand sanitizer. I'm going to line up the ends. I see that the hand sanitizer is shorter, so it's going to go over here on the shorter side. And we'll continue to do this as we sort objects and determine whether objects are shorter, the same, or longer.
One of the IOAs that our students will work with in Unit 4 is IOA 7B, classify and sort up to 10 objects into categories by an attribute, count the number of objects in each category, and sort the categories by count. We will continue our work with this IOA at the concrete level. The one piece that is going to be different from this unit and our previous units is we will now do that last learning target of this IOA. So for the first time, after we sort our objects into categories by an attribute, after we count the number in each category, we will now sort the categories by count. So let's look at what this might look like. Rita has a set of buttons in a bowl. She would like to sort her buttons and figure out how many of each category she has. What attribute can Rita use to sort her buttons? And how many of each category does she have? So I'm going to go ahead and start by pouring these buttons out. And I just want to look at these buttons. I'm going to spread them all out so I can see them. Okay, so what am I noticing? Well, one thing I'm noticing is that we have a very small button, and then we have some larger buttons. I could use size to sort these buttons. I could sort them into small, medium, and large, or just small and large. I'm also noticing all of these buttons over here are circles, and this one is not a circle. It's a bunch of bananas. So maybe I could sort them by shape. I notice that some have 2 holes, some have 4 holes. I could sort that way. And another thing that I'm noticing, an attribute of these buttons, is the color. I see different color buttons. That's a way that I could sort them. And I'm going to choose to sort them by color. So let me see. I'm going to go ahead, since I have an orange one here, I'm going to move all my orange buttons over. I'm then going to take my green buttons. Here's my pink button. And then here are my black buttons. So I've sorted them by color. Color is the attribute I used. I want to count to see how many are in each category. Well, I notice in my orange, I have 1, 2, 3, 4. I can represent the number 4, how many are in that group, with a written numeral. So there's my 4. For green, I see 1, 2, 3 buttons. So I'm going to represent the number of green buttons with the numeral 3. I only have 1 pink button, so I'm going to represent that with the with the written numeral 1. Here's my 1. I know it's kind of hard. Make sure you guys can see it. And then when I look at my black buttons, I see 1, 2, 3. So I can represent that with a written numeral as well. So Rita could sort her buttons by color. And then she has 4 orange buttons, 3 green buttons, 1 pink button, and 3 black buttons. The piece that will be new for our students with this IOA is that we're now going to move into sorting them by count. And so we can do that with them. And so to sort them by count, what that really means is now I want to organize my buttons by quantity. So what I'm noticing is I only have 1 pink button. That's the fewest. So I'm going to go ahead and move it over. Let me get it to where I can make sure you guys can see it. So there's my 1 pink button. And then, oops, I need to move my 4 because 4 is my biggest number. I have 1, 4, and 3. 4 is the biggest. So I'm going to move it all the way down to the other end. Let me take those 4 buttons. And then I notice that I have 3 green and 3 black. So this is the same. Maybe I just go ahead and leave my 3 there, and I'm just going to move these 3 down here. I'm putting them on top of each other because this is showing me that I have the same. Sorry, guys, my number 3 is written down there as well. I know it's hard for y'all to see everything under the document camera. But what I've done now is I've sorted my buttons by count. So now they're in numerical order. I have 1 pink button. I have 3 green and 3 black buttons. And then the most is 4 orange buttons. So this will be the piece that is new. I do suggest that this is, of course, at the concrete level. I would have my students use some sort of sticky note or index card where they can write the number on it and then move it around with the buttons instead of writing it on the piece of paper. So that'll be a strategy that is very helpful for your students as they then, after they've sorted by whatever attribute they use, they can then resort by count, and it'll be easier for them to move them around.
In mathematics, the emphasis is on the reasoning and thinking about the quantities within mathematical contexts. Specific mathematics strategies for teaching and learning are not mandated by the Georgia Department of Education or assessed on state or federally mandated tests. Students may solve problems in different ways and have the flexibility to choose a mathematical strategy that allows them to make sense of and strategically solve problems using efficient methods that are most comfortable for and make sense to them. It is critical that teachers and parents remain partners to help each child grow to become a mathematically literate citizen. These standards preserve and affirm local control and flexibility. From the Georgia DOE's Comprehensive Grade Level Overview.